Alright, lesson 3 of our polynomial review, multiplying monomials.
How do I multiply monomials? How do I simplify expressions involving power of monomials?
Alright, so what is a monomial? Like we've discussed before, a monomial is a number, like 1 or negative 100. It can be a variable, like a or x or y, or it can be the product of a number and one or more variables, like 11ab or 8a to the 12th b cubed. Here is examples of some terms that are monomials and some that are not monomials, so they are non-examples. Things that are not monomials. So this is just a plain number, a plain variable, product of one number and x to the cubed, product of a number and two variables, and this is also a monomial even though this says 1/2. That's still just a number and some variables. This column in the non-examples, things that are not monomials, the a and b is separated by a plus. You can only have multiplication. This is division, subtraction, division, division. That's what makes all of these not monomials. Alright, any monomial that is just a plain old number is a constant. And here are some examples of constants. It's okay for it to be negative. It's okay for it to be fraction. It's okay for it to be a decimal. Alright, now let's talk about exponents and powers. So x to the n is a power. What you call the big number, the x, it's called the base. The little number to its right is called the exponent. So this is my base. This is my exponent. Alright, this is the product rule for exponents. If you have any two numbers or any number a and they have exponents of m and n, as long as they have the same base, with multiplication you rewrite the base and you add the exponents. Alright, so here are some examples. I have three terms I'm multiplying together. They all have a base of a. So I rewrite the base and I add my exponents. 4 plus 7 plus 10 gives me a to the 17th. Same thing here. All have the same base. So I rewrite the base and I add my exponents. 41 plus 2 is 43 plus 40 is 73. Alright, next one. A little bit different because now I have a coefficient in front of them. So what I do is I multiply my coefficients. 5 times 1 is 5. Rewrite my base and I add my exponents. 3 plus 6 plus 1. Even though there's nothing written down there, there's an implied 1. So there's my answer. Alright, more. Same thing. Multiply my coefficients. 5 times 4 is 20. Rewrite my base. Add my exponents. Same thing. Monomials are just a little bit longer. Multiply my coefficients. Negative times positive is negative. Rewrite my base with my a's. I have 1 plus 9, so that gives me a to the 10th. Now I rewrite my b's and I add together my exponents with my b's. 2 plus 10 is 12. And then I rewrite my c and I add together my exponents with the c. Alright, number 6, same thing. Multiply my coefficients. 8 times negative 3 is negative 24, and then I multiply that by 1/2. That gives me negative 12. And let's see here. So I'm going to do my x's first. I have an x here and an x here. So I rewrite my base of x and I add my exponents with those x's. 2 plus 1 is 3. Then I'm just doing them in alphabetical order. Then I do my y's. Here's a y, here's a y, here's a y. And I add my 3 plus 2 is 5 plus 4 is 9. And there's my answer. Alright, let's see if you can do these by yourself. So see if you can multiply them. Remember, you're using the power product rule. So multiply your coefficients, rewrite your base, or bases and add your exponents. So stop the video, give it a try, and restart when you're ready to check. So here's what I got. Hopefully we got the same thing. If we didn't, ask me some questions tomorrow. Alright, remember whenever we've raised a number to a power, the power tells us how many times to write that number. So if we raise 8 to the third to the 5th power, that means we have 8 to the third 5 times. And all those 8 to the thirds have the same base, so we rewrite the base and we add our exponents. 3 plus 3 plus 3 plus 3 is 15. So 8 to the 15th. And the same thing here. I'm going to take this quantity y to the 7th, and that 3 means I'm going to rewrite it 3 times. And I know for my product rule, I rewrite my base and I add my exponent. 7 plus 7 plus 7 is 21. So here, if 8 to the 3rd raised to the 5th power is 8 to the 15th, and y to the 7th raised to the 3rd power is y to the 21st, these examples suggest that you can find the power of a power by multiplying the exponents, which leads us to the power of a power rule. So if you have a base and you have an exponent and it's raised to, that quantity is raised to a power, all you do is multiply your exponents. So b to the 10th to the 3rd power, 10 times 3 is 30, so it's b to the 30th power. R to the 5th to the 12th, I multiply those two. Rewrite my base, multiply my exponents, r to the 60th. And also, this is the power of a product rule. So if I have a quantity a to the b and I'm raising it to the m power, all I do is distribute that exponent to everything inside. I'm going to raise a to the m power and b to the m power. So here's my examples here. If I raise a b to the 4th, that means I'm going to raise a to the 4th and b to the 4th. And the same thing happens if I have a coefficient inside here. I have 5pq to the 5th, so I'm going to distribute that 5th, and I'm going to do 5 to the 5th, p to the 5th, q to the 5th. 5 to the 5th is 3,125, and then I have q to the 5th, p to the 5th. Here is an example with a pair of a monomial. So if I have a quantity a to the nth power, b to the nth power, and I always raise it to the p power, it's the power to a power rule. I just distribute that p, and I multiply it with my exponents that are already there inside. So here, an example, I have 2a to the 4th, b, all raised to the 3rd power. So I distribute that 3, 2 to the 3rd power, a to the 4th to the 3rd power, and b to the 3rd power. I raise 2 to the 3rd power, which gives me 8. I multiply my exponents with a, which gives me a to the 12th. And this is a 1 here, so it's 1 times 3, and it's b to the 3rd. Alright, when simplifying expressions, there's 3 things you got to make sure of. That there's no powers to a power. So you have to do all the multiplication, and you can't have a power to a power where it's not simplified. Each base can only appear one time. So you can't have x squared times x. You have to have x to the 3rd. Because that x squared to the x, that base is appearing twice. It can only appear once. And all fractions must be in simplest form. Basically, on this first one, it's a power to a power, so all I do is multiply. So I have a to the 99th power. Same thing here. I have this quantity raised to the 4th power, so I rewrite a, and 5 times 4 is 20. I rewrite my base b. 7 times 4 is 28, and I rewrite my base c, and 2 times 4 is 8. Now on this one, I have a coefficient in here, so I have to raise the 5 to the 3rd power, the m to the 6 to the 3rd power, and the n to the 3rd power. 5 to the 3rd is 5 times 5 times 5, which is 125. Power to a power, I multiply, m to the 16th. And power to a power, I multiply. There's a 1 implied there, so it's n to the 3rd. Okay, so let's see if you can do these. So, give it a shot on your own. Restart the video when you're ready to check. So, pause the video now. Okay, hopefully we got the same thing. If we didn't, ask me some questions about it tomorrow. All right, one, and here. Let's see. You do these and see what you come up with here on the first one. So pause the video and give these two a shot. Alright, if you'll notice in the second problem that this -8 was in the front of the parentheses, so it was not part of the quantity raised to the third power. So I did not raise -8 to the third power. What I did is I raised 3 to the third power, and then after I got that, I had to multiply that by -8 to get myself -216. Alright, now here is finally, I think, we're almost at the end. Here's an interesting little fact. If I take, no matter what power I raise 1 to, if I raise, no matter how many times I multiply 1 by itself, I get a 1. So, but here's the thing, when I take it and make it a -1, if I have a negative exponent and I raise it to an odd power, I always get a negative number. And if I have a negative number and I raise it to an even power, I always get a positive number. So -1 to the 99th power is equal to -1. And -1 to the 98th power, since it's even, is equal to a positive 1. And here is, I think, the last two for you to try. So let's pause the video, give these two a shot, or here, no, I'll just go through and tell you how to do these, because this is basically orders of operation. We have to do exponents before multiplication. So -5 to the second power squared. -5 times -5 is 25. Z to the 7th raised to the second power, multiply them, and then I have to take that and I have to multiply that by my 4z to the 9th. So with multiplication rules, I multiply your coefficients, I rewrite my base, and I add my exponents. And on this last one, distribute the square. So I'm going to square my 5 and square my 6. 5 squared is 25, 6 squared is 36. And then I'm going to rewrite my base, and I'm going to multiply 6 times 2 is 12. I'm going to rewrite my base 2, and I'm going to multiply 7 times 2 is 14. And I'm going to rewrite my base u, and I'm going to multiply 8 times 12 is 16. And that's it. That's all of our multiplication rules.